Hello and welcome. In this video, I'm going to show you how to work with our causal AI tool, Whyond. Currently, you have two major options, the creation of causal models as well as causal inference. Moreover, on the left side of the screen, you can also navigate and change between creation and inference. Let's select causal model creation. We now have three options. Loading an existing model from our local hard drive or loading a model from cloud storage. Such existing models can be inspected or modified. For this video, however, we select the third option, which is creating a new causal model from scratch. At first, we need to give a name for the model. Let it be discount, because we want to analyze for a retailer if a discount campaign actually yielded more revenue. Now let's add the very first node to the model by clicking on the corresponding button on the top of the window. In the ensuing dialog, we type the name, which is revenue, and an abbreviation. A short and easy abbreviation is pretty handy, so I'll simply type R. Additionally, there are more options which are less relevant for now, so I'll skip them. And here is the note. Whyond automatically added an exogenous parent variable. Down here, we can hide it. Now let's add discount, abbreviated by D. As discount directly influences the revenue, we now draw an edge from D to R. Then our retailer gave us some additional information about the discount campaign. At the beginning of this year's January, he reduced prices by a lot in order to raise them continuously till the end of the month. So we add a third node named week of January, which obviously has a direct effect on discount. Now, let's select the revenues node and click on Enter Distributions. Then a piece of rudimentary Python code appears. We now modify the formula. As giving discount makes less money, we type a minus in front of D. Then we have to click Accept. The revenue node now has this gear symbol, meaning that a mechanism is given. As we are in an economy where people tend to get monthly salaries and have more to spend at the beginning of a month than at the end of it, there is also a direct effect of week of January on revenue, so we draw the corresponding edge. Now a problem appears. The gear symbol on the revenue node was replaced by a red cross. That's because the mechanism is no longer valid. Week of January is not considered in the Python code. We can fix this by opening again the mechanism dialog and clicking on Reset Default Mechanism. A side effect of this is that the minus in front of D is gone, but we adapt the mechanism accordingly. Minus 2 times D minus 12 times WOJ plus 2 times U underscore R. The formula for discount will be minus 2 times WOJ plus 0.5 times U underscore D. Now let me tell you about the exogenous variables. By default, a standard normal distribution is assigned to them. For discount, we'll stick to normal distribution, but we change the mean to 10 and the standard deviation to 3. Similarly, for U underscore R, we pick 20 as mean and 3 as standard deviation. In case of week of January's exogenous parent, we use a different distribution. We have a few options to pick from. If we select other distribution, we can type a SciPy method that's not amongst these options. So let's take, for instance, a beta distribution and use the parameters A equals 1.2 and B equals 1.7. There we go. Here's the plot of the density function. However, as our expert recommended, we decide to take a uniform distribution from 0 to 4 instead. Okay, so we're almost done. For a clear arrangement, we can select a different layout of our graph. and then we can save the model online by clicking on the Save button. Additionally, we can also save it on our local device by clicking on the Export button. That's it about model creation. In the next segment, I'll talk about using our model for causal inference.